So we dealt with proportions, and now we're going to look at percents, folks. Last night was proportions, or last video was proportions. This one's percents. Percents in algebra. What I usually try to say to my kids is that percents equals cents. Percent is cents. So for example, if I'm thinking 8% as an interest rate, maybe on a credit card that I have to pay, if I want to change that to a decimal, write it in terms of how many cents that would be. And that is an easy way to remember percent is cents. And you can quickly change a percent into a decimal, and you don't have to stress about which way do I move my decimal point. I can't remember. Either way, even if you logically just knew that 8% was 0.08, then you're good, but this will always help you put it into your mind so that you can remember how to set that up. So we're going to be looking at dealing with percents problems from an algebraic standpoint, which yes means we're going to be writing variable equations. Let's jump in. Okay, the word percent, it comes from the Latin per centum. The Latin word centum means 100, so this is probably something you've looked at before with your stems in language arts. A century, 100 years. A centenarian is a person who has lived for over 100 years. There are 100 cents in a dollar. You know that a centimeter is 1/100th of a meter. So we know that prefix. In the dictionary it says percentage is the result obtained by multiplying a quantity by a percent. So the percentage is the same thing as the part. And we commonly use percentage and part as the same thing. And there are two methods for dealing with these problems. One is the proportion method, so that'll be familiar from last year and last time. And the other one is the equation method. And for the proportion method, you have the part or percentage over the base or the whole thing is equal to the percent, make circles for me, there we go, over 100. And that is the basic percent proportion. Sometimes they call the base the whole thing, so you might say the whole, and the percentage might have been known for you as the part. But either way, those are the words we're going to be using. The percent equation is a little bit different. It's P for percentage equals R times B. Okay, and again, P is percentage, again, also known as the part. The B is the base, and that's the whole thing. The R is the rate, and that is the percent as a decimal, or in decimal form, the percent as a decimal. So those are the two methods we'll be using, and out of the proportion or the equation, one of the different values will be a percent, one of the three unknown values. So when I say three unknown values, I'm saying either the percentage, the base, or the percent will be a variable. And over here, one of these three unknown values, the percentage, the rate, which is the percent as a decimal, and the base. Now, it should be obvious that they're related, but let me make sure we understand how they're related. The rate is the percent as a decimal. What do you get when you divide a percent by 100? You get the percent as a decimal. So they are related. One uses a decimal and one uses a proportion. It depends on what you're more comfortable with. I'll do a couple of each. Let's jump in and do some. Here we have 4% problems, and we're going to use either our proportion or our equation to solve them. I'm going to start with the first one, and for the first one I'm going to go ahead and use my percent proportion. So for number one, what percent of 50 is 60? So I'm going to go ahead and draw my proportion lines. I know my 100 always goes in the same spot. What percent of 50 is 60? Well, of 50 means 50 is the base. Is 60? 60 is the part or percentage. Now that is a little counterintuitive because you're thinking, how can that be? 60 is bigger than 50. Well, look carefully at the question. What percent of 50 is that 60? It's going to be more than 100% because your 60 is bigger than 50. Your percentage is bigger than the whole thing or the base. All right, cross multiply and solve. The answer is 120%. You can use percents bigger than 100 for all kinds of things. We tend to talk about the stock market in terms of that stock had over 120% increase. That means it more than doubled. 100% increase would be doubling. So 120% increase would be more than doubling. So that's something to be thinking about. Let's do the second one with the percent equation. So P equals RB. What is 35% of 80? Well, R is your percent as a decimal. 35% would be 35 cents. All right. What is 35% of 80? So 80 is my base. So this is not an equation I have to solve. It ends up just being something to evaluate. And what do you get for what is 35% of 80? I got 28. Did you get 28? So say that you had an $80 meal and it was a really good meal and your server was just spectacular. They probably didn't spit in your food or anything. And you want to give them a massive tip. On an $80 bill, a 35% tip would be $28, which is a pretty darn good bill. Or a pretty darn good tip, I should say. So 28 was the answer to that one. Excellent. Moving forward, let's do the next one, also using the percent equation. So I'll stay with my red. 75% of what number is 36? So P equals RB. 75% again, that's a rate. That's 75% is 75 cents. We don't know the base. So in this case, this is one we will have to solve. Is 36. So 36 is the part of the percentage. And we're going to use division to solve. And what did you get for the value of the base here? 75% of what is 36? I got 48. Did you get 48? Sometimes I feel like I'm making a baby Einstein movie because I tend to talk to you guys even though you don't talk back. I probably shouldn't do that. Anyway, let's move on. Number 4. How much interest will you earn by investing $1,200 at a simple interest rate of 2.5% a year for 6 years? For this one, we require a formula that we learned last year in pre-algebra. So I'm going to put number 4 up here. And that is I equals PERT, I equals PRT. And so I stands for interest, and that's what we're finding. The P is the principal, the amount of money you invest. The R is the rate, that's the percent as a decimal. And the time is in number of years. So we put our 1,200 in. We are going to put in our rate, and that's our percent as a decimal. Now be careful with this. 2.5%, remember, is 0.0025 as a decimal. So I kind of hemmed myself in there. I could barely fit it in there. Go ahead and multiply it and think carefully. Remember, 2.5% is a tiny amount. So if you miss a decimal point somewhere, you're going to get a gigantic amount of interest, and 2.5% is just not a very big interest rate. So remember that your value will be smaller, especially remember that it will be smaller than 1,200. Seems too small, doesn't it? $18 for 6 years. For 6 years. But yes, that's an interest rate of 2.5%. Remember, an interest rate of 2.5% means 2.5 cents per dollar invested. Okay, so those interest rates are not very high, and that's because that would be what we call a low-risk investment. So, not low risk. Let's fix that. Hold on. Sorry. Sometimes I make sound effects, if you haven't noticed. Okay, so those are the basic percentage problems. Now, of course, the word problems will get more complicated, and I especially want us to go over a particular type of investment word problem that is a great deal more involved than number 4. And this is the problem that I'm talking about. Let's read through it. Ms. Blackman invested $8,000, part at 4% and the rest at 5% per year. How much did she invest at each rate if her total return for the year of the investment was $380? So, this is a little more realistic. When an individual is investing, they want to look at the different things that they can invest in, and you want to be thinking about different types of things like risk, for example. The higher the investment, okay, so usually the greater the return, the greater the risk. And the reason that we want to think about that is that if you want to put all your stuff in low-risk investments, that's all well and good, but you're not going to get as much money back at the end. If you put it all in high-risk investments, you run the risk of losing it. So it's important to recognize what this stuff actually means, and this is a more realistic problem than just our straight simple interest. We are still going to use the same formula. So the basis for our equation is going to be that formula right there. So first we've got to think about what are we going to use to represent the amount that we're trying to find. We're trying to find how much she invested at each rate. So let's start off by identifying our variable. Let's make x represent the amount of money invested at 4%. How can I express the amount of money invested at 5%? And don't say why. We don't do two variable equations yet. How can I express the money invested at 5%? Well, if X is the money invested at 4%, and there's 8,000 total, we can take our 8,000 total and subtract X. There we go. So what we're going to end up having is our I equals, and you're going to have PRT for one investment plus PRT for the other part of the investment. And we know our interest already. They told us that was $380. What we do not know is our principal for each of the two accounts. So in the first one, we'll do the money invested at 4%. So our principal would be X. Our rate would be 4% as a decimal, 0.04. And our time, it tells us that her return per year. So our time is 1 year. Plus, now let's look at the second half. We need our amount invested at 5%, which is 8,000 minus X. We put in our rate. Our interest rate, remember, is percent as a decimal, and again, it's still just for 1 year. So I know that looks super complicated, but slow down and think about what we did. We identified the value for what money will be invested at 4%. We said the rest of it is invested at 5%, and we identified our formula and filled in the formula. Now we have to solve it. So I've got 380 equals 0.04x, because times 1 doesn't do anything, plus 8,000 minus x times 0.05. And I'm going to have to distribute. So I have 380 equals 400ths x plus 400 minus 0.05x. I can combine my like terms, giving me negative 0.01x plus 400. I'm going to go ahead and flip it around with my symmetric property, good old symmetric property. I'm going to subtract 400 from each side, giving me negative 0.01x equals 20. And then I'm going to divide. Now be very careful here. Do not try to mental math this out and mess it up. Think carefully. You're dividing by a decimal. You're going to get a number bigger than 20. So 20 divided by 0.01. Excuse me, that's a negative 20 there, wasn't it? No wonder. I was about to get a negative answer. We can't invest negative dollars. We can have a crappy investment, but we can't invest negative dollars. All right. Now we know the amount invested at 4%. So the amount invested at 4% is $2,000. How can I figure out the amount invested at 5%? Well, remember, it's 8,000 minus X. $8,000 minus $2,000 is $6,000. And now we know what Ms. Blackman invested. $2,000 at 4% and $6,000 at 5%. Okay, they're not that difficult if you map it out. I'm going to have you try one on your own on the next slide. All right. A total of $9,000 was invested, part at 6% and part at 3%. If the annual return from both investments was $396, how much was invested at each rate? Copy it down, please, or at least take notes from the problem, and try it yourself. Use the other problem as an example. I'm going to pause it, write it out, and solve it for you so that you can see it when you're done. Okay, now pause it and try it yourself. This is important for you. Don't just keep going and watch me do it. Okay, and now I'll go ahead and pause it myself and write it out. And here we go. So we have our variable expressions, x and 9,000 minus x. You have p times r times t for the 6% part of the investment, p times r times t for the 3% part of the investment. We solve the equation. We got $4,200 for x, so that means $4,200 were invested at 6%. And do the subtraction. Can you hear the little buttons of my TI-84 calculator being punched? I got $4,800 for the 3% investment. Go back and double check it. You can do that really quickly on your calculator by finding 0.06 times 4,200 plus 0.03 times 4,800 And we should, and yes, indeed, I do get 396. And that should cover it for this video. Hopefully I made it under 16 minutes. I don't think I quite made it under 15 minutes. And I will see you in class.